Recording in progress.
Yeah, hi. Hi, Aman, what is your doubt?
Yes.
Good. version. That is okay. That's okay.
That is fine, right?
That's fine. That's fine.
Okay, why it is happening? Like any specific reason? It is taking the environment version.
No, it is taking the base environment. You have not set any environments. No, it's possible to create some virtual environments, and by default, it will take the base environment. You haven't set any environments. So that's why it is showing the base one. That's okay.
Okay.
People are still joining. Maybe one more minute, we'll wait. Okay, I think that's it. Let's start. So, so last class we had talked about the different sequence types, right? And then we talked about the properties which are common to all the sequence types, right? So today we will see what is special in each sequence, in each type of sequence. So to do a recap, we have just a moment. So the common things that we saw, right? So we saw that all sequences have positional indexing. So this we used for identifying different elements in a sequence, right? And then we saw that they are all iterable. Then list and tuple, you can put heterogeneous, it's a heterogeneous sequence. So that means you can put any data type into it. String is homogeneous, right? So only characters. So this any data type. Right? So this is what we had seen in the last class. And some common methods also, right? So methods like length, min, and max, which can be applied on all sequences. And also, we talked about the concatenation operation. So if you say plus, it won't add. You can't perform arithmetic operations. Plus will concat and star will repeat, right? So this is a repetition operation. So these are the common things that you can do on any sequence, right? So whatever we have seen till now applies to list, tuple, and string. So next we'll see what is special about list, right? So what all things can you do with list? Then what can be done with a tuple? What is the difference between list and a tuple, right? So here we said this is immutable and that is mutable. So we will try to understand what that means. And why do we need tuples? Okay. So yeah. So let's start with the list. So let me rerun what we have run already. So if you have opened yesterday's file, you need to run all the cells, right? So otherwise that will not be available. So you have to say kernel, restart and run all cells. Okay, so this will run everything. So now list methods. What all operations can you perform on a list? So I think I have a list called LST. This is my list, right? So if you want to see what all operations can be done, right? So if it is numeric, we know arithmetic operations can be done. So depending upon the data type, there are certain things that you can do with it. There are things that you cannot do with it. So if you talk about numeric data types, all arithmetic operations can be performed on this. Other than this, you cannot do anything else. And when you talk about Boolean type, logical operations is what you can perform on it, right? So other things don't make sense. So similarly, when you say list, what operations can we do, right? So when you see tuple, what operations can be done? And for string, what are the operations we can perform, right? So this is what we need to understand. Other than what we see here, you can't do anything else. So if you want to know what all can be done with a list, you can just say dir, right? So you can say dir and within brackets, you say list. So if you come to the very end, right? So you can ignore all this double underscore. I told you when we were naming variables, I said we should not use, it's better not to use double underscore, right? So that is because Python internally uses them. So ignore that, starting from here, right? So these are what are called the methods of a list. So these are the operations that can be performed on a list. Other than what you see here, we can't do anything else, right? So what are these methods? These methods are meant to work with list objects. So what all things can we do with a list, right? So when you have a list or any collection, we should be able to add elements to it. Then we should be able to remove elements from it. Then we should be able to update it, right? So then possibly you should be able to sort or order it. These are all some of the common things that should be done on any collection, anything other than a basic variable, any other things, right? So any type of collection, any type of data structure, you should be able to do all this. So that is what we will be doing here, right? So these methods allow you to perform those operations. So first thing, let us see how you can add elements to a list, right? So how do we add elements? So the first thing you can do is you can use the append method. So append will add elements at the end of the list, right? So now if I say LST dot append 100, right? So now if you look at LST, 100 will be added at the end of the list. So whichever list you take, right? So let us say a shopping list, shop underscore LST, which we had created yesterday. Let's say I want to add a paper to this or notebook to this. So I'll say shop underscore list dot append notebook. So now if I see what is there in shop list, notebook will be added to the end, right? So this is how you can add an element to the end of the list, right? You can try if you want, or
Ma'am, can we add multiple elements?
yeah, that's what. Let me finish all the adding and then you can try. Right, so I'll show you all the methods that can be used to add elements. So first one is append, right? So this will add to the end of the list. So if you want to add something in between, right? So let us say between butter and jam, I want to add bread, right? So here I want to add bread. So what is that position? 0, 1, 2, 3, right? So I want the third element to be bread. So if I want to add it somewhere in between, then I have to say insert, right? Because append can only add at the end. So I'll say shop underscore LST dot insert at what position, right? So at position 3, I want to insert bread. So now if you see what is there in shop list, can you see bread has been added as the third at index position 3. So insert is used to add an element somewhere in between, right? So now like somebody asked, what if I want to add multiple elements at the same time? So in that case, you can only add it at the end, right? So you can say shop underscore LST dot extend. And then I have to specify the list of values that I want to add, right? So let's say I want to add soap. I want coffee. And I want, let's say, milk. So now if you see shop underscore LST, you can see soap, coffee, and milk have been added at the end. Right? So these are the 3 ways in which you can add elements to a list. You can append, which will add to the end. Insert will add at any position you want. And multiple elements at a time, if you want to enter, you have to use extend. So you can try these now. Try these quickly and let me know.
When by showing the result in the vertical format instead of horizontal after the extend command.
No, that is just if it goes too big, then it will put it like this. It's just a way of displaying. You have many items, it will show one after the other. Done. Okay, let us move on. So we have seen how to add elements, right? So now we'll see how to remove elements.
Ma'am,
Ah,
in the previous 94th line,
ah,
you have written extend. After that, you have open a parenthesis.
ah,
Again, big bracket is there. Is it
so
necessary to add that one?
yeah.
Because in the answer also we are getting that parenthesis.
Okay, what is this parenthesis?
Mm.
I'm also getting the same error, syntax error, unterminated string literal.
And no, he's not getting an error. He is asking this. So whenever you are, I'll check your error. So,
Yeah,
so
it's working. It's working. Sorry, I
you
miss a
forgot,
inverted comma.
you forgot apostrophe. See, this means it is a function, right? So
Okay.
function can take parameters. So here we are providing a list of values as a parameter.
Okay.
That's why you need all these brackets.
But if in answer, if I don't want that parenthesis, big bracket, then what to do?
No, see, don't say big bracket because you know this is a list.
Okay.
They are working with lists. So it will obviously return a list only,
Okay.
right? Don't call it big parenthesis. This is a list of values. Right. So let us remove elements, right? So if you want to remove elements, so we can do the opposite of append. So append will keep adding elements to the end. So there is a method called pop, which will remove elements from the end of the list, right? So this is your list. So if you say lst.pop, this will remove element 100 from this. So now if you see what is there in list, only up to 38, right? So again, if you say list.pop, 38 will be taken out and you will have only up to 90. So pop will keep removing elements from the end of the list. So you can say this is the opposite of append, right? So append will keep adding to the end. Pop will keep removing from the end. How about if you want to remove from the middle, right? So you want to remove something in the middle. So let's take our shopping list. That is easier to look at. Let's say I want to remove jam. Where is jam? Jam is at position 0, 1, 2, 3, 4. Right? So I can say shop list dot pop 4. So if I mention a number here, right, so it will remove element from that particular position. If you don't mention any number, it will automatically remove from the end, right? So jam will be gone. And if you check your shop list, no jam, right? So the rest of the elements are available here. So pop is the opposite of insert, right? So insert allows you to enter value at a particular index position. Pop will allow you to, pop followed by a number will allow you to remove element from that position. But if you don't know the position, right? So you don't want to count where it is. I just want to remove coffee from my list. So in that case, instead of giving the index, you can just say shop list dot remove, right? So remove method, you don't have to give index. You just say what you want to remove, but you have to be careful about the capital letter and all. You have to type it exactly like you have given. So now wherever coffee is, it will be removed, right? So you don't have to see where it is located and give the index and all. So now you see coffee is gone. So remove should be followed by which element to remove. All the other things take the index position, right? So remove will remove an element from your list. What if you want to remove 87 from LST? I don't have to count if error is 87, right? So instead I'll say lst dot remove 87. I don't want 87. Now if you see, 87 will be gone from your list, right? So that is remove. And the last thing you can do is you can say lst dot clear. This will remove all the elements from the list. Now, if you check what is there in the list, you get a empty list, right? So there is nothing inside this list. So these are the different ways of removing elements. Okay, so let me comment this out so you can see everything in one. Yeah. So you can try these 4 methods quickly.
Ma'am, please scroll up a little bit.
This is the first thing.
Ma'am,
Yeah,
ma'am,
yeah.
ma'am, if we had same number 2 times, for example, 78 2 times, if we want to remove both 78 at a time, what we want to do, ma'am?
That is not possible.
That is not possible.
That's not possible. You'll have to do it one at a time.
Ma'am, whatever we need to remove are those things case sensitive?
Yes. How to open new file when your home page opens? You can just say new and Python 3. That will open a new file.
Ma'am,
Yeah.
can I share my screen? I am not able to debug where exactly I'm going wrong.
Yeah.
Here, ma'am.
1 second. Let's still share. Remove coffee. Coffee is not there in the list. I think you've already removed it. Can you print list?
It is here, ma'am.
No, try printing it, shop underscore list.
Okay. Earlier, actually, I removed. Again, I. Okay.
Again, if you try, it will say it is not there.
Okay. Okay.
Right. Yeah. Done? Okay. So let me create this list once again. Where did I create it? Because I removed everything from the list. I have to create it again. Okay, let's take this one, right? So LS1. So now let us see how we can do ordering of list, right? So ordering in the sense you can arrange in ascending, descending, you can reverse a list. So ordering a list. So this is a list. So if I want to arrange it in ascending order, right? So I can just say ls1 dot sort. Priya, what is the error you are getting? If you want, you can share your screen quickly. Meanwhile, others, please create a list. Here you can share. Are you sharing?
Ma'am, I can't share, ma'am. Please wait. I'll share later.
Share later. All right. So create a list like this, right? So now if I want to arrange this in order, I'll say ls1 dot sort. Now, if you see what is there in ls1, it has been arranged in ascending order, right? Smallest is 34, largest is 90, so it will arrange it in ascending order. So if you have all strings, right? So if you take your shopping list, and if you say shop list dot sort, it will arrange it in alphabetical order, right? So if I say sort, then shop underscore list, if you see, it has arranged this in alphabetical order. So if you have numbers, it will arrange in ascending order. If you have strings, it will arrange it in alphabetical order, right? So what if I want to arrange this in descending order? So in that case, I have to say ls1 dot sort, and within this, I have to say reverse is equal to true. So now, if you see ls1, it would be arranged in descending order. Same for shopping lists, right? So if you want soap, shampoo, rice, so if you want this in reverse alphabetical order, you have to say shop list dot sort, and within brackets, you will say reverse is equal to true. Right? So this is for arranging in descending order. So there is a method called reverse, right? So reverse will just reverse a list. It will not order or anything, right? So if you have a list, which is, let's say 437. If I say L1 dot reverse, what will happen? This will become 734. Right? So sorting and reversing are different. So if I say LST dot sort and reverse is equal to true, what will happen? It will arrange this in descending order. Right? So that will be 743. But reverse doesn't care about the order. It will just take the list and put it in reverse order. That's all. Right? So let us create a small list and try to reverse it. L1 is equal to, let's say 78, 65, 90. So now if I say L1 dot reverse. And if you look at L1, 90, 65, and 78, right? So it will just reverse it. So this is how you can change the order of a list. You can either sort it in ascending or descending order, or you can reverse it, right? So you can quickly try this.
Ma'am, hello?
Yeah, tell me.
Ma'am, when we do L1 dot sort of reverse is equal to true,
Huh.
for example, let us say the list is 135902. So it will simply take from like descending order, is it? It will not sort it or something like that.
Sorting basically is arranging in ascending or descending order.
Yeah, sorting I understood. Like
Ah.
if I say 213, it will do 123.
Ah.
Okay. But if I do sort of reverse is equal to true,
That
if I
is
have
arranging. See, sorting basically means arranging in either ascending or descending order,
okay,
right? So based on the values, if you are arranging, that is sorting. So 1, 2, 3, this is ascending order. 3, 2, 1, this is sorting in descending order.
okay, ma'am. For example, let's say 135
Ah,
902.
okay.
Now, if I say sort, it will give me 0 1 2 3 5 9.
Yeah.
Now, if I say list sort of reverse is equal to true for the
Ah,
first one,
ah.
let us assume that I have not done sorting.
No, you don't have to do sorting. You can just say sort reverse is equal to true on this one. It will automatically sort it.
So it will give me
9,
9.
5, 3, 2, 1, 0.
Okay, so it is not like it will give me 209531.
What is that? No, that is reverse. This is L1 dot reverse.
Okay. So
This,
if I say sort of reverse is equal to true, it will give me a sorted reverse.
sorted reverse.
Okay. Thank you.
Let me know once you're done.
Ma'am,
Yeah,
once a code is executed, I
ah,
cannot go back
you
with the
can
earlier. Hmm.
you can go back, but if you have made changes to your list, then you
Mhm.
have to again create it. If you want the original list, you have to create it once again.
Okay. No other option to again call it back with any
No,
number.
no, you can't undo it. You have to again create a new list. Scroll a little down. Yeah.
Ma'am,
Ah,
so sort reverse is either it will be in ascending or descending order, and reverse means it will interchange the position, right?
it will just reverse it. That's all.
Okay.
Okay. So okay. So the next thing we can do is you can see how many times an element is occurring, right? How many times something is occurring in a list. So let's say I have a name list where I have Tom, Tim, John, Jim, Tom, Jim, Kim. This is my name list. So I want to know how many times, let's say I have one more Jim. I want to know how many Toms are there in my name list. So I can just say name list dot count Tom. So it will say there are 2 Toms in the list, right? So if you say count how many Jims are there are 3 Jims. How many Kims are there? There is only one Kim, I think. So count followed by something, it will tell you how many times a particular element is available in the list. Right, so it counts the number of occurrences. One more, let me show you, and then you can do. Then you have index, right? So index method. So this will tell you the first occurrence, right? What is the position of the first occurrence of a particular value? So if you see this list, there are so many Toms, right? So if I say name list dot index of Tom, it will tell you where is the first occurrence of Tom, right? So Tom is occurring first where? It is occurring at the 0th position. So the position of first occurrence of Tom is 0. How about Jim? Where is the first occurrence of Jim? Name list dot index of Jim. So Jim is the first time Jim is occurring, it is at the 3rd index position. So index will tell you where is the first occurrence of the element that you are searching. Right. So count and Tom, index are 2 additional things that you can do on a list. Done. Why Tom index is 0 and Jim is 3? Where is Tom occurring for the first time? That is what index gives you, no? So where is the first occurrence of Tom? It is at index position 0. Where is the first occurrence of Jim? It is at index position 3.
No, we can't get second occurrence and third occurrence.
That is not possible, but you can say start looking from here. Right, so you can say start looking from a particular position. So if you look from here, Tom will be occurring at this. This is the first occurrence of Tom. So that will be 0, 1, 2, 3, 4. That is all you can say. Right, so you can say start looking from the second index position. So if you say Tom, comma 2. So after position 2, where is the first occurrence of Tom? That is all you can do. Can't get all the occurrences.
Means it will get the second occurrence, no?
But then we don't know whether it is second occurrence or not, no? See, if you can see the list, then of course you know this is the second occurrence. But if you have a list which has thousands of records,
Then what 2 represents, ma'am?
2 represents starting from here. Starting from this position, where is Tom occurring for the first time?
Yeah, okay.
Right, you start searching from here onwards. So beyond this, where is Tom first?
Yeah, okay.
Ma'am, but Tom is in first also. Here.
That is what, if you just say what is the index of Tom, it will say 0. Right, but if you say you start looking from here and tell me where is Tom coming first, it will say starting from here, this is where Tom is occurring for the first time.
Why like that? Like,
Sorry?
okay. Is there any definition for that?
See, basically it says what is the first occurrence of Tom. So by default, it will start searching from the beginning of the list. So you have an option to say from where should I start searching. So you say start searching from here, but whatever it is, it will give you the first occurrence of Tom. Starting from either 0 or from this. 0, you don't have to specifically say. All right. So I think if you
Ma'am,
see,
if I want how many times Tom has come in the list?
that you cannot. There is no method like that. You will have to write a loop and you will have to count. How many times is possible? Count will give you how many times. But every time which occurrence you won't know. See here, count of Tom tells you there are 2 Toms in the list. Count of Jim tells you there are 3 Jims. But
The
if
index it will not say at which position it has come.
the first occurrence it will say, but if you want to know every index position for Jim, then you have to write a loop. Right, so Jim is here, here, and here. If you want that, then you have to write a loop. Okay, so now, so if you come to this, we have seen most of the things here. We know append, clear, count, extend, index, insert, pop, remove, reverse sort, right? So only thing that is pending is copy. So other than that, we have seen all the methods. So when you say copy, right? So let us say I have a list. L1 is 1, 2, 3. Now I say L2 is equal to L1. What will be there? And if I print L1, what will I get?
1, 2, 3.
If I print L2,
1, 2, 3.
this will be 1, 2, 3. Now I'll say L2 dot append 100. If I print L2, what will I get?
1 to 300.
1, 2, 3, and 100.
What will be there in L1?
1 to 3.
1, 2, 3.
Actually, if you see L1, you here also you will get 100. Right? So why does this happen?
But
Because
madam, we have defined L2 as L1, not L1 as L2.
yeah, but we did that earlier only, no? I created L1, then I put L1 into L2. Then I changed L2, of course, L2 changes. But why should L1 change? Right? So what happens here is, when you say L2 is equal to, so when you say L1 is equal to 1, 2, 3, in memory, right? So a memory space will be created for L1. 1, 2, 3 will be put into it. And this location will be given a name L1. So whenever you say L1, it will say 1, 2, 3. When you say L2 is equal to L1, it does not create one more list. Instead, what it will do, the same list will be given one more name called L2. So whether you say L1 or L2, we are referring to the same object. There is only one list. So now I said L2 dot append, right? So what happens? 100 gets appended here. Now if I say show me L1, it will show this. If I say L2, it will show this because only one object is created. You might think I have two lists, one called L1 and one called L2, but that is not the case. Right? So when you say L2 is equal to L1, actually the same object is given two different names. So whichever name you use, it's the same object that is getting updated. But what if you want to, your intention was to create a copy of this, right? So you wanted two objects having the same values. So if that is your intention, then you have to say L1 is equal to L2 dot copy. Sorry, L2 is equal to L1 dot copy, right? So L2 is equal to L1 dot copy. So in that case, what will happen? L1 will be 1, 2, 3. Another object called L2 will be created, which is a copy of this. So now there are two objects. So now if I say L2 dot append, this gets appended. So if you print L2, you will see 1, 2, 300, but L1 will remain unchanged here. L1 will have only 1, 2, 3. Is this clear, the difference between these two? Right, so this is very important because you might think that I have taken a backup. Right, so here you thought I have taken a backup of L1. So L1 won't get changed, only L2 will get changed, but that is not the case. Any change you do to L2 will be reflected in L1 also because you did not create two objects. If your intention is to have two objects and keep one as such and make changes to the other, then you have to say copy. Okay, so let us try this out. So first thing what we are doing is called assignment. Right, so when you say L2 is equal to L1, we are doing assignment. So L1 is equal to 1, 2, 3, right? And then I say L2 is equal to L1. So this is called the assignment operation. Now I'll say, so let's print L1. Let's print L2. Now I'll say L2 dot append 100. And now I print L2, 1, 2, 300. But if you print L1 also, that also has changed, right? So which we didn't expect. So now what we do, we will do a copy operation. We'll do copy instead of assignment, right? So again, let me redo this. L1 is equal to 1, 2, 3. L2 is equal to L1 dot copy. So L1 is 1, 2, 3. L2 is also 1, 2, 3. Right. So now I say L2 dot append 100. So L2 would have changed, but L1 will remain unchanged. Okay, so whenever you want to take a backup, always use copy. Otherwise, both objects will get updated at the same time. Okay, you can try this. All right. So let's take a small break and come back. Right. So we are done with all list methods. We'll see other data types. So we'll come back at 1:10.
हम्म. तर वो ऑनलाईन साठी तुला आता हे करते ना फोर्स करते ऑनलाईन लीजिए
Ma'am,
Give me a few minutes. We'll start at 1:10. Okay.
just scroll up, ma'am, your screen. In the index section, you go.
Yeah, hi. So are you all back? Okay, so we have seen all the methods of list, right? So the other two data types, other two sequence types, that is list and tuple. Sorry, list and string. So what is the difference between list and the other two? List is mutable. The other two, right? So tuple and string are immutable. They are both immutable. So what do we mean by mutable or immutable, right? So mutable means you can access the memory. So if I say L1 is equal to 1, 2, 3, right? So what happens? A memory space is created. 1, 2, 3 is put inside this. And because it is a list, right? So because it is a list, you are allowed to access this. So that means you can make changes to this memory location. So if I append something, right? So what happens? I have to go inside and write it. Right? So that means I'm able to access this memory location. If you're removing something, then again, I have to go inside and remove this. So unless I have permission to access this location, I can't do any of this. Right? So this is what we mean by mutable. You can make changes to the memory. But when you say immutable, right? So let us say you have created a tuple with 1, 2, 3. Once it is created, right? So tuple also creates a memory, 1, 2, 3. But once it is created, you cannot touch it. It is like you have put it inside a glass case, right? So it is like you have put it inside a glass container. You can look at it, but you cannot change it. Once the object is created, once you do this, this is closed. So if I want to append, I have to go inside and write. I can't do that. If I want to remove something, I have to go inside and do, right? So which it will not allow. So that is what we mean by immutable. So if you look at all these methods, right, of list, which methods can we do for a tuple here? Can we do append?
No, ma'am.
No. Can we clear?
No, ma'am.
Copy is not allowed. Count?
Yes.
Yes.
You can
Yes.
count because you can see it, right? Extend?
No, ma'am.
No. Index?
Yes, ma'am.
Yeah, because we can just look at it and count it, right? So we are not making changes. Insert?
No.
No. Pop?
No.
Remove?
No.
No. Reverse and sort also no, right? Because what happens when you say reverse or sort, here itself it gets changed, right? So 3, 2, 1. So unless you can access this, you cannot reverse or sort or anything. So what are the only two things that are allowed? You can count and you can find the index, right? So if you check what are the methods of, let me copy this. If you see what are the methods allowed in a tuple, right? So tuple methods. How do we check that? We can say dir of tuple. And you can see only two things are allowed, right? So you can do count, you can find the index. So let me make this into a tuple, name tuple. So I'll just convert this into a tuple. So if I try to append something, it will not allow, right? So name tuple, name dot append and all is not allowed, right? But if I try count, name underscore tup dot count how many times Tom occurs, that is possible. I can also find the index dot index of Tom or Jim or something. Index of Jim. So other than count and index, you cannot perform any operation on a tuple, right? Now coming to strings, string methods. There are plenty of methods in string, right? But we can't go through everything, right? So we will just look at a few of those. Can you see so many methods are there? Capitalize, case fold, center, count, encode, ends with. So let's try a few of these, right? So let us say I have a string S1 which says I allow Python. So if I say S1 dot capitalize, what happened? Why nothing happened? Okay. There was a space. Huh. So now what happened? The first letter, right? So first letter got capitalized. I became capital I. But if I say S1 dot title, now what happened? The first letter of every word got capitalized, right? So you can convert everything into capitals. You can say S1 dot upper. This will convert everything into uppercase, right? So let's say I have S2, which says Python is great, right? So now if I say S2 dot lower, everything will get converted into lowercase. There is something called swap case. So this will convert capitals to lower and lowercase to uppercase. Right? So can you see? P, I, and G have become lowercase, everything else has become uppercase. So it will just reverse it. It will swap the case of the letters. Right? So these are some things that you can do. You can check if something ends with, right? So let us say my S3. Why this hangs sometimes. Okay, S3. What did we want to do? Ends with. So let's say it is called Python. So I can say, see if S3 starts with PY. Does it start with PY? It starts with PY, so it will say true, right? I can see if S3 starts with ON. Does it start with ON? No, right? So it will say false. So similarly, you can check S3 ends with PY. That will be false. But S3 ends with ON. That is true. Right? So that will return true. So you can check whether something starts with something, ends with something. Then you can strip. But stripping, how to show, I don't know. Okay. Okay, let me try to, let's say S4 is equal to space Python space. Right, so S4 dot R strip. What happened? Can you see? See, this space to the right has been removed. You don't see any space here. But the space on the left is still retained. Right? So R strip will remove spaces from the right. L strip, what do you think it will do? It will remove the spaces from the
Left.
Right? And if you say strip, it will remove from both. Strip will remove from both left and right. Then you have a replace method, right? So let us say, where did I have Python is great, right? So S2. So S2 says Python is great, right? So now I say S2 dot replace great with boring. What happened? Great got replaced with boring, right? So you can replace a string with some other string. Then something very useful is this, what do you say, the split and join method, right? So let's say I have a sentence. Let's say Python is great, right? So S2. So if I say S2 dot split, what happened? The sentence got split into different words and it was put inside a list. So this returns a list. Can you see it is returning a list of values? and it is taking each word out and creating a list made of these words. So it is splitting it into words and putting it inside a list, right? Or we can have a big sentence. Yes, 5. This is a big sentence for what? For demonstrating the split method. So now if you say sy.split, it will take out all the words from it and it will create a list out of it, right? So here by default, it will split it based on the space, but you can say split it based on some other character, right? So let us say our S6 is apple, orange, kiwi, and grapes. So this is my string. Now I can say S6 dot split based on the comma character, right? So now it will split this based on comma, and it will take our apple, orange, kiwi, and grapes and put it into a list. But instead of this, if you had something else, right? So like this separator, you can say split this based on this character, right? So you can say S6 dot split based on this, right? So this is your split method. So your join method is the exact opposite of split. It will take words from a list and create a sentence out of it, right? So let us say I have a list L1, which contains the words the, comma, coffee, comma, is, comma, hot, right? So this is a list of words. So I can say L1 dot so I have to specify the what is the separator, right? Dot join L1. So here what we are saying is join this based on and give a space in between those, which is the opposite of split, right? So we are saying split based on blank spaces. Here we are saying join, but use blank spaces in between. If you give some other thing, it will add that in between the words, right? So join will do the exact opposite of split. It will take values from a list, attach it together, and create a sentence. So we had a shopping list. So if I want to create a sentence out of this, I can just say this dot join shop underscore lst dot, right? It converted it into a single sentence. Or if you want to take a list and you want to convert it into a comma separated values, you can do this, right? So apple, bread, butter, milk. So this is your join method. So these are all very useful methods when you are working with the strings, right? So there are so many others which you may not use that frequently, but these are some of the commonly used string methods. So now the question is, string is also immutable. right? How come we are able to do so many methods when tuple we cannot do anything? You should have asked, no? Tuple you said is immutable. And only 2 methods we were able to do, but with string we are doing so many things, no? How?
String is homogeneous.
But it's also immutable. Homogeneous means it is made up of characters, that's all. So, so one thing you need to always keep in mind later on also, right? Whenever you execute some function, here I have executed the capitalized function. So whenever you run this, if you see an output is getting thrown out, then it means S1 is not changed, right? This is a new object. This is a new object. So that means you can assign it to a different object if you want. You can say new object is equal to this. So this will go inside the new object. S1 itself is not changed. So what I'm saying is, if I say S1 is equal to hello, right? So what happens? In memory, you have S1, HELLO. This you cannot touch. So when you say S1 dot upper, what happens? A new object is created, which has HELLO, and this is what is getting displayed. But this object does not have any name associated with it. So you cannot access it again. Right? So you won't get the capitalized version of it again. If you see what is there in S1, S1 will still be the small letter only. Right? So if you try that, see, this is our S1. I say S1 dot upper, but S1 has not changed. What is there in S1? You still have small letter only. So this is a new object. How will I access this new one? I can't do that, right? So because it doesn't have a name. But if you want to give it a name, if you want to access this separately, you can assign it, right? So this you can put it into S2. So this will become S2. And now you have S1, which is capital, S2, which is the capital version, and S1, you have the original version, right? So both you will have access to. So I can just say S2 is equal to S1 dot upper. Now, if you see what is there in S2, uppercase, S1 still has the lowercase. Right? So this is always the case whenever you see an output is coming from a method, it means the original one has not changed. Right? But if you see this list methods, okay, I'll write it here. See, I have L1 is equal to 1, 2, 3. So now I'm saying L1 dot reverse. Do I see any output? There is no output coming out. So what does it mean? L1 itself got changed. Right? So there is no separate object. L1 is mutable. Right? So list is mutable. So here, when you said this dot reverse, this memory got rewritten as 2, 3, 2, 1. Right? So this went off and this memory itself got changed. So L1 itself got changed. But here string is immutable, so you cannot change this. So what string is doing, it is creating a separate object, and there you have the capitalized version. Are you clear? So anytime you see an output coming, you should keep this in mind when we are doing, data frames and all. Because you might think that you have changed your string to uppercase, but actually you have not changed it, right? So only a copy has been created. So either you should, you have to make sure this is changed, or you have to put it into a new variable so that this will be, the changed version will be available. Okay, so this is what happens internally when you say, this is what we mean by what is mutable and immutable, right? So there was something that I wanted to say. Forgot.
Ma'am, shall I ask one question?
Yeah, sure.
Just go to the split section. There, ma'am, a space is been created after comma. Like apple is there, comma, orange. Before orange, space is there. We have not given anywhere a space. Then how it is coming?
This you're saying?
Yes, ma'am.
No, that is not a value. This is just a spacing that Python is giving for readability purpose. If you see a space after this, then you can say something we have given. Right?
Okay, so here a space is not being recognized as a character.
No, there are no spaces here. No, if it is there, it will recognize it as a character. But here you are only printing it. Python is just printing it by giving some spaces here. It is
And
not
there,
part of the data.
okay.
Right? So that is not part of the data. See here also, right? So here we didn't give any space. But when Python is printing, it will give some space for readability. That's all.
Yeah, it is by default.
It's by default. Python is printing it like that. It hasn't given any additional elements inside it.
And if I give purposefully, then it will again add one more space, right?
Where do you want to give space?
Like before orange in S6.
If you give this, this
Okay.
space will become part of this string. Right, 1 second. Let me execute this. Can you see? That
Yes.
becomes part of the string.
Okay. Okay, nice. Thank you.
All right, so we are done with all the sequence methods. So now, should we go to dictionaries or? Yeah, let us go to dictionaries.
Ma'am,
Yeah,
can we use join for strings also?
can we?
Can we use join for strings also?
For strings only we have done, no?
Like giving the elements in string. Here we are giving individual elements in the in list map. Here we can also give in string.
No, you are saying
Here L1
yeah.
is list map. We can also give L1 in string.
So you want something like this?
Yes, ma'am.
This dot join S1. You can give a tuple also. Right, so T1 is equal to 1, 2, 3. Dot join T1. What happened? Oh, str, you can only join string instances. So I'll make it A, B, E. Right. So you can give any sequence here. It will take the elements out of it and join them together and create a string.
Yeah, okay.
By the way, I forgot to run this. That is why it is giving I love Python. So that should have been hello. Yeah. Yeah. So before we move on, right? So there is something special in Python, which is called list comprehension. This is a very, very Pythonic thing, right? So it is very specific to Python. So if you are a Python developer, you will be using this a lot. So while list comprehension is used to create one list based on another list, right? So let us say I have a list L1 or LST, which has 1, 2, 3, 4, 5, 6, 7, 8, 9. So, or let it be 10 also, right? So now I want to create another list, which is the square of all of this. So I want 1 squared, 2 squared, 3 squared. So I want the new list to contain 1, 4, 9, 16, 25 like that. So normally if you're writing, what you will do, you have to write a loop, right? So I'll create a new list is equal to an empty list. And then I'll say for I in list. Do you remember what this will do? It will take one element at a time and it will perform some operation on it, right? So this is called iterating over the list. So first I will take the value 1. So now what I will do, I will say new underscore list dot append I to the power of 2. What will happen now? Can you tell me how this will work? So when you say new list is equal to this, an empty list will be created, right? So this creates an empty list. I haven't put anything inside the list. Now I'm saying for I in LST. So first I will take the value 1. Now I'm saying new list dot append 1 into 1. So what will happen? 1 gets added to the end of the list. There is nothing, so end is 1. Then during the next iteration, what happens? I is equal to 2. So now I'll say new list dot append 2 power 2, right? So that means 4 will get appended to the end of the list. Then I will be 3, append 3 squared. I will be 4, append 4 squared. I will be 5, append 5 squared. I will be 6, append 6 squared, right? So I will be 7, append 49. I will be 8, 64, 9, 81, and this. So a new list will be created which contains all these values, which is what we wanted, right? So I hope you are clear with the logic, how this is working. So if you see what is there in the new list, I have a list which contains the square of all the values from another list. So this is the traditional way of writing. So when you, so Python uses list comprehension, which is a shortcut way of doing this, right? So here, if you are using list comprehension, let me create another list, right? So square list is equal to, I will say, I power 2 for I in LST. This set of code has been rewritten like this in a single line. So now if I see what is there in square list, did I get the same result? Right, but I have used a shortcut way of writing this. So how do you interpret this? See, what this means is create an empty list. And what you want to add to the list, you specify here. What do you want? You want the squares, right? So you will just say something to the power of 2 is what we want to add. But from where is I coming? I is coming from this loop. I takes the first value from this, squares it and adds it to the list. Then I'll take the second value from this list, squares it and adds it to the list. So whatever you specify here gets added to the list. And from where is I is coming? I is coming from here. Right? So this is called list comprehension. This is very, very peculiar to Python. So if you are a Python developer, you definitely will be using statements like this. Can you try this? Done. Can you try this? Take the same list, create another list which contains 100, 200, 300, 400, up to 1000. From this list, I want you to create this list. Right? List comprehension.
Okay.
Yeah. Repeat the question. I want you to create a list which contains these values. You have to create it from this list.
I star 100 for I in list.
Yes. Right. So you just, so whatever you want to add, you will, yeah, that is correct. Amol, you are also right. Right. So you will just say LST2. Right. So LST2 is equal to, what do we want to add here? I into 100 for I in LST. Right. So now if you see what is there in LST2, you will have what you wanted, right? So what if I want to take out, right? So I have this list and I want to create a new list which contains only odd numbers, right? So in that case, what I can do is odd underscore nums is equal to, right? So again, I can use a list comprehension. I will take I, right? So for I in LST, but I will add one condition, right? So if, what is the condition? What did I want? Even number or odd numbers, right? So I percentage 2 equal to 1. So what does this mean? Or let me take a simpler example and then we'll come to this. Let's say my list has 9 minus 8, 7 minus 6, 5 minus 4, 3, 2 minus 1. So let's say I want to take out all the uh, positive numbers. So I'll say for I in L1 than 0. Right. So now what does it mean? It won't directly take I from L1 and put it here. It will take I from L1 and it will check if I is greater than 0. Only if this is satisfied, it will put it here. If it is not satisfied, it will not put it here. Right? So it will take I from L1 and if that I happens to be greater than 0, add it here. So now if you see your pos underscore nums, you have only positive numbers. All negative numbers have been taken out. Right? So this also you can do. You can add a condition also and create a list. So yeah, so this is how you can do list comprehension. Okay. So this is something very special in Python. You will be expected to know this. All right. So I'll share this in your drive.
Ma'am,
You
can share it normally, ma'am, file. Like drive is not working for me.
Drive will work for everybody. Why it won't work for you? I'll share, no problem. Let me upload, I'll share. So I'll overwrite it once again. Classwork, added course. Yeah, I'll replace. I will also upload here. Fine, then let's stop for the day. Right. So tomorrow we will continue with the other data types.
Thank you, ma'am.
Yeah. Have a nice day. Bye.